So our next presentation will be about the Methods Hub from the Pistoia lines, and I believe Steve Emrick from USP is going to kick us off. All yours, Steve.
Hey, thank you, Vinny. Can everyone hear me?
Yes.
Excellent. Thanks, everyone. I'm very happy to be here today and talk a little bit about, okay, I backed up. I'm really happy to be here this morning, and I'm joined by my colleague, VanDerwall, and I'm not sure if Gerhard is on the line or not, but I'd like to take a little bit of time to talk about some projects that have been going on at the Pistoia Alliance and in collaboration with the Allotrope Foundation to really what I would describe as an application that leverages the AFO and Allotrope data models to build a framework and even a platform that provides digitalization and interoperability of analytical methods. So I'm going to talk a little bit about the background of each of these things, methods database, methods on demand, and then an emerging body of work related to data standardization of chromatography columns. And then I'm going to talk about where else might we need to provide some focus on this work to meet the needs of the community. So why are we doing this? Well, there's a cost to things not being interoperable and not being reproducible. There's one study by Friedman and colleagues that says that claims that data reproducibility continues to be a costly problem in life sciences that adds up to almost $28 billion a year. Now, not all of that is related to analytical methods and labs, but there's a slice of it, around 10% according to that study. So everybody knows that not having things in an interoperable format leads to one-off implementations, difficult mappings that are hard to maintain, and that does cost money. And I think that many of us in the industry, including USP, as we're going through this digitalization journey, have experienced these issues where we've got lots of different systems that speak different languages that are costly to maintain, and then you need some type of data framework and standard to solve for those problems and lead to better interoperability and reproducibility. So methods are no different. There are many things that are stored in paper formats and manually kept, or they might be stored in proprietary software platforms. So our hypothesis here is that improving both the automation and the interoperability of analytical methods can lead to improved quality, optimize efficiency, reduce cost, and even lead to innovations around machine learning. Once you've got all that data standards framework in place, you can start to actually leverage those for predictive analytics. And this will help to improve things that are high value use cases that we've heard from the industry related to effectively transferring methods, enabling digitally transferable methods, B2B from CRO to pharma, from one lab to another lab. This will reduce the need to do manual data entry. This is something that, as my role at USP, we hear from our customers all the time. We give people PDFs, and then they have to kludge those things into their system somehow, which provides a risk for us, because when people are trying to leverage our content for proving quality of medicines, that becomes more risky as they do these one-off implementations and we don't have visibility to it. So I wanted to frame this up and kind of test this framework. I was thinking about the difference between machine readability and interoperability, because a lot of the times in our organizations, we get these questions from our executive teams. Well, why are you doing this? What is the value here? What's the importance? We've already got a system that does X, Y, Z. We've already got a system over here that does X, Y, Z. And making the argument around interoperability is something that's not always that easy. And so I created this visualization, and I'm going to test it internally, but I thought I would test it here first. And I'm thinking that many of us in our individual companies live in this upper left quadrant where you've got machine readability, but not great standardization. And so you do have things that are, You can automate things, you can scale things, but that only applies to your local institution or your company. When you start to talk about sharing data across sites or to a CRO or even to regulators, that gets very hard. Some of us, and I would say maybe even at USP, we might live in that lower right quadrant where we do have standards. We publish standards for a long time, but they live in paper formats that don't have any digital capability at all. And then people have to do things to make that work in their electronic environments. And that reduces the impact of those standards because they don't live within electronic workflows. So making the journey towards the upper right quadrant where you've got a combination of machine readability and standardization gives you that ability to do not only enterprise analytics, but then reproducibility and transfer from site to site. And that's a big paradigm shift there that we're seeing in the industry, and something that I think this project uniquely supports. So with that, I'm going to start, and Dana, can I hand it off to you here to describe the three projects, or the two projects?
Yeah, sure. So the concept of the Methods Hub really is kind of an aggregation of a couple of projects we'll describe in more detail. But the idea is that it's really envisioned to be and grow into a platform where semantically defined and interoperable analytical methods and related tools are available to the industry. And this speaks to the things that Steve was just talking about in terms of supporting the automation for the high-value use cases where there's a transfer between methods and regulatory or methods and or industry and regulatory industry and CROs. And really includes driving the standardization, continuing to define the elements of the data and the data models that leverage not only the Allotrope ontologies, but also the ADF. And it was in this first bucket that we established the agreement between Allotrope and Foundation and Pistoia to create this project to work under the Pistoia alliance flag with members and start to build out something more like a solution based on the standards and framework that Allotrope develops, which kind of reflects our complementary reasons to be, if you will. And so to date, there's been a pilot implementation of the methods database. There's some really interesting work going on in the methods on demand space, which we'll describe in more detail in a second, but basically using NLP to parse things that are in text. And then the next step is to build out an asset that doesn't exist apparently at this point, but which we came to the conclusion would be very useful, a database of chromatography columns and their associated data. So historically we kind of started with well, actually, very historically, we did a POC in the first year of Allotrope Foundation when we were still evaluating other standards and approaches and things like that. And so the exciting part about the methods database is that really sort of revisited that concept of defining a method in a standard format and really instantiated in what at that point was in the new Allotrope format. So the first phase defined, the chromatography data system parameters that were needed for methods because there was a richer set than what had been defined from the standpoint of results. And then, building a data model to fit with the rest of the data modeling approach. And then, ultimately the first instance of a methods database is something that's hosted on Ostis's Zontal space. And so you might recognize Zontal space, having heard about it in terms of, being a data hub or a data repository. Well, it turns out that if you're going to store a method in an ADF file, that anything that stores ADF files can help start to support, your needs for a method database. We'll talk a little bit more about some of the other features. The next phase of the project is where, we started working on fleshing out the adapters for Agilent OpenLab and for Waters and Power to integrate the methods in the digital format. So this allows both an movement back and forth between the methods database and the chromatography systems. And there's some POCs underway for some of the member companies to implement those. And then there's some plans in the future to sort of extend that the next step and be able to package methods and data in the same file format in the way that it was always kind of conceived of in the first place. So the methods on demand is a new interesting process. So there's already a lot of information out there, a lot of methods that are not digital that one might want to convert. So this starts by taking the free text content, or the text content that was provided by USP, CAS, and Elsevier, and many thanks to them, and using NLP algorithms with the AFO and the chemical methods ontology behind that to identify entities within those methods. And that's kind of the first step of figuring out how to digitize them, but at least they're mapped at that point. And that's kind of there's been a first pass of that in the review that's underway. And then, I'll leave it to Steve to talk a little bit about the chromatography column database. There we go. Oops. Yeah. So I think, as I mentioned, this was kind of the initial focus on this business problem that Steve had articulated. The recapitulation of methods and the difficulty in sharing them and retranslating them between systems. And so wanted to instantiate that digital version of it. And so, after looking at the chromatography workflow, looking at what wasn't already in the chromatography data model and aspects of the ontology, and then focusing on, the more commonly used terminologies across systems, because, some systems actually do have different technology. And at that point, there does need to be vendor-specific terminology, but starting with the stuff that was common and then building a data model for that and implementing it in the Zontal solution was the first phase. And so this kind of illustrates that with Zontal and the methods DB in the middle, the upload and download capabilities that were introduced, the ability to sort of search it, and then a first example of producing a human readable report, because there will still be need for that, right? The whole world isn't going to now deal with a digital object for a method. So, but once you've captured in this control vocabulary with the right template, you can output a report that starts to look a little bit more about what we're accustomed to dealing with now. And this phase 2 bit and then deals with these new functionality of these adapters, as well as building in some additional capabilities to the information modeling. So a little bit of extra metadata to help link into the ELN and LIMS systems. So kind of holding places, if you will, for some of your kind of more internal pieces of information. Extending the method model for column descriptions, which is where sort of instances of columns from the database would plug in. And then also sequencing parameters, so that now the method model will be able to do more than, code for more than just one run, if you will. And, looking forward on the roadmap, we get to a point, as Steve mentioned, we kind of close the loop on this, where with a methods database centrally being able to support the download to instrument control systems or upload to newly created methods in a vendor agnostic way, in a very robust way, to be able to import, and input things from monographs and publications and convert them that way. And then once we start being able to sort of associate those with the results that were generated as part of an analytical workflow, you're picking up the context of that workflow from here and providing results back. You've got this new space that's ready to be populated with advanced analytics. So getting data off a machine, knowing what it was, what method was supposed to be run, powering analytics to either, if your method development, make adjustments to improve separation, or if you're doing QC, enable a comparison to what the standard should look like, and these kinds of things, or maybe error detection, sort of based on baseline or, drift and test samples and that kind of thing. But with the method and the results digitized, you're in a position to start enabling that kind of thing. And I'll hand off to Steve for methods on demand.
Thanks, Dana. So the methods on demand, I would say, is a project that aims to it's a continuation and a scaling of what was done in the methods database to account for the large volumes of literature and publications containing analytical methods that have already been written out as free text. So if you ask people to take all that information and say, well, how would you map this into the AFO or the CHMO or other data standards and ontologies? There's a lot of interpretation there. There's a lot of time that would be spent there and it would cost a lot of money. So what we wanted to do is develop a process, an agile process that uses NLP that can begin to mine out those entities that are in the domain in this first phase of chromatography data system parameters and sample prep, because that seems to be the highest value use cases for now. And that process can be scaled, it can be consistent, it can be agile. It kind of has to be agile because what we found in the initial phase of the pilot is that there are things that NLP is not going to be able to detect out of the box unless you fine-tune some of the training to account for some of the ontological nuances. So I think that we're learning a lot in this phase, and we hope to be able to apply what we're learning in the NLP to scale across the volumes of literature and provide access into the platform of many of these methods that have already been written. So Dana, I'm going to hand it back to you.
Yeah, so and this is an interesting time to sort of look back, and in 2015, when we were in early days in developing the Allotrope ontology, we were having conversations within our community and with scientists, at large, outside of the community and experts at the APN about, whether it's actually really possible to take something like this paragraph from a paper, experimental procedure, and map all this detail to an ontology, to a controlled vocabulary. What would that really look like? It was deemed a little bit sort of too daunting, like boiling the ocean. And this wasn't just for the methods part. This was even in order to sort of, bring along that which is required just for the context around the results. So we did this thought experiment and said, well, if we take this paragraph and we try to identify things that could be mapped to vocabulary, it was actually quite a lot of text theoretically that could be, and then so kind of manually compared that to the ontology as it was developing at the time and pointed out sort of what domains that fell into. What's fun though now at this point in time, we're hitting an interesting milestone, is that I'm now applying the NLP in the first pass with the AFO and the CHMO behind it. That same paragraph, now we can actually go out and pick up those entities, sort of illustrating now that we're into that space now of being able to digitize something like that. Now you'll see that there are things that we didn't map yet, and that's part of that process improvement that Steve spoke to. And back to you, Steve.
Thanks, Dana. So part of what we had identified in phase 2 of methods DB was a need for better data standardization and better data modeling around chromatography columns. The original plan was to leverage some of the assets that USP has. We have a chromatography column database that indicates what class of column was used for a given method within a monograph. But we realized that that wasn't quite sufficient, and there's some additional data elements that are needed, as well as a model to provide information and insight to the analytical chemist as to which columns might be suitable. So here's the summary of what we're trying to solve for, and please keep in mind that we're beginning to form the project team around this and beginning to test the use cases and the value proposition. So we welcome your thoughts from the participants on the call. So currently there's a lack of standardization in column metadata. This impedes the ability to, when you scan one column from a vendor, it might not work if that's not the same brand. And so there's a need to standardize those metadata for accurate and comprehensive descriptions. And then there's no standard data model that can relate the methods to potentially suitable or similar columns, and this may lengthen method development time. So standardizing the chromatography column metadata might provide benefits for method development and execution, and tracking column history and utilization, and column inventory. So here's a summary of those use cases that I mentioned: development, method authoring and approval, and method execution. And like I said, we're just beginning to form the project team. I'm the co-lead of this, along with my colleague Kang Zhu from Johnson & Johnson. And we've got some people interested in the Pistoia Alliance that have expressed interest to be on the team. And then we're going to be meeting next month to be able to refine the use cases and the value proposition. And then we'll be beginning to develop the project plan and hopefully implementation this summer. So to summarize, some of the next steps related to each of these projects in the platform. For Methods DB, we definitely are interested in recruiting some more companies that might want to join in the implementation testing. For Methods on Demand, we've completed the first cut of the NLP gap analysis and mapping to the AFO and CHMO ontologies. And now we're reviewing that body of work right now, and we're looking at, do we need to potentially fine-tune some of those algorithms and rerun them again? Or is what we got sufficient to figure out where these free text entities live and how we can scale that process across many, many different sources of data? And maybe we need additional sources of data to further train these algorithms. And then we want to expand that work into other instrumentation and techniques. We constrained it to the domain of HPLC and sample prep for now, but we might want to go into other instrumentation as we go forward to account for that. With the Chrome columns, we're just getting started. And then I thought it would be also good, we've got these, we're starting to build out these themes of things that support method interoperability, column standardization, NLP that can be used to provide a consistent way to mine out those terms. But are there other things that we should be considering that might fit into this platform? And that's a question that I pose to the attendees here. So please don't hesitate to contact any of us listed here, Dana, myself, or Gerhard, with suggestions or questions or next steps that you feel are relevant. So with that, I think, oh, I'm sorry. I wanted to list out the companies that have participated so far in the Methods DB and Methods on Demand. And with that, we'll open it up for questions from the group.
Hey, Steve, maybe we could also just touch on, those things that, output of these various work streams where something's coming back into the Allotrope Foundation for governance and inclusion. And so, I mean, the first was definitely, the method data model and updates on that, which has been governed and is actually released as part of the data models that are available. I suppose that probably introduced new terminology, but I guess it also is safe to say that in the process of, the NLP work, we'll be identifying, potentially identifying terms that are needed to describe methods we didn't catch the first time that we'd feed back in. Are there other things that I'm not thinking of? I guess there's the stuff around the sequencing and some of that sort of thing, and maybe there's some stuff around, columns that would be submitted for extensions to the model as well.
That's right, Dana, and thanks for bringing it up. I mean, we're essentially providing use cases into Allotrope to model into the ontology and create new data models. So if there are entities that are pulled out from the literature that haven't been previously identified, we would submit those for governance and even for data model creation. I think that's the intent of the extension Methods on Demand work, and even the chromatography columns, where what is that data model to effectively link the column information to the appropriate, or the method information to the suitable columns information.
Yeah. And we had a question along the way that I'll state the question, then I'm gonna punt and invite see if there's somebody from Ostis, either Jan or Wolfgang or somebody else on the semantics team that wants to address it. But there's a really interesting question about, so we can recognize the entities and we map things in text to an ontology entity. Is there a way, or what's next around to capturing the relationships between those recognized entities in the text? And you know, if one of the Ostis colleagues wants to raise their hand, Jamie can unmute you if you want to venture an answer at that.
Wolfgang here. Hi. So one of the steps that we need to do once we have identified the entities of interest, we need to bring them into a structure, right? So either we have a predefined model that we data model that we populate, so where we know exactly this is a template where we need to feed in those values, or if it's more human workflow centric, which can happen in the sample prep, right? Maybe we need to do a part of speech analysis, really then to understand the grammar of the sentence, how those terms all relate together.
And yeah, that's great. And while you're on, Wolfgang, there's a question that I'm not sure I know that you might. And is there an intent to release the trained NLP models generated as part of this project to either, you know, the Pistoia, the Allotrope communities?
Not sure. I'm not following this project or this part of the project that closely. I would need to discuss. I don't know.
I don't remember that coming up, Steve. We will have to revisit that one, I guess. I think we're kind of using canned stuff right now, but it might make it more sophisticated eventually.
I think it will. So I mean, we can take that back to the project and find out if there's a demand for that. Then that's a discussion we could have. There was an example that pops into my head, Dana, that we looked at together, where you had the term column temperature that didn't map into anything, and that's a commonly used term, and we were like, well, where is that within AFO? And it turns out it is in there. It's just that it's not a pre-coordinated term, column temperature. You've got a column that has a property of a temperature in it, and then a value that's assigned to that. So that's an example of where we might go back and fine-tune the NLP in kind of an agile way.
Yeah. And then finally, there was one comment or a question / suggestion. Have you considered reaching out to Dwight Stoll at Gustavus Adolphus for the chromatography project? He's apparently developed an extensive LC stationary phase database. Is that anything you or anybody else in the project were aware of? I wasn't.
No, I'm not aware of it. I will take that up. So thank you, Wes, for mentioning that.
Yeah, thank you.
Okay, thanks. And I think, Jamie, just maybe one more question. I think there's one hand raised. I think we have one final question. If you could just unmute.
So Matt, you're unmuted now if you want to ask your question.
Oh, yeah, it was really quick, Steve. So I think Michael Watts in our chemistries group would probably love to speak to you about that. But you went past the slide with your email address on really quickly and I didn't catch it.
I apologize.
spe@usp.org, perfectly.
Yeah,
Perfect.
and no worries. Just for the audience, all the slides will be made available at some point after the meeting, so you don't have to furiously jot things down unless you need to speak to Steve today. So
slides and videos on our YouTube channel. Thank you, everybody.
Yeah, absolutely. Thank you, Steve, and thank you,
Thanks
Dana.
a lot, everyone.
Yeah, and again, I encourage folks to reach out to both of them to continue the dialogue offline.